Hello, this is Sadbir. The topic of our discussion in this video is the slope field of first order differential equation. What is slope field? Slope field is also known as vector field or direction field. It is a tool to graphically obtain the solution of first order differential equation. Here I'm going to consider this example to explain this concept more. So my example is dy by dx is equal to x plus 1, and I will plot the slope field of this differential equation. So we already know from the calculus that dy by dx, which is the derivative of the function y with respect to x, it represents the slope of tangent line, the slope of tangent line y is equal to fx at some point x0 comma y0. So it is the slope of the tangent line. So in order to plot the slope field, what I will do, I will first have my xy plane. So this is my x values and I will plot my y values here. So I will also have a table where I independently choose my x and y. And since dy by dx is the slope of the tangent line, so I will basically calculate the slope of tangent line here, which is in this case x plus 1. Here I will choose x and here I choose y. So if I choose my x and y is equal to 0, it means this is the point where x and y both are 0. So if I plug that into my slope, and I will get the value of my slope is 1. So here in the slope field, I will draw a tangent line whose slope is 1, but I will draw a very tiny tangent line whose slope is 1 in the slope field. So if I choose now my x is equal to 0 and y is equal to 1, or another of this point, which is equal to x value is 0 and y is 1, and I plug that one to my basically this function, which is x plus 1, and it will give me again slope 1. So the slope 1, it means this line is parallel to this. With the same x component is always gonna give me the slope 1. So even if I choose x is equal to 4, y is equal to -1, y is equal to -2, and so on, all the tangent line at this point are going to have slope 1. Now notice if I choose x is equal to 1 and y is equal to 0, this is gonna give me the slope 2. It means at this point, the slope of the tangent line is 2. It means this line is more steeper than the one which I draw here. And also notice if I take x is equal to 1 and y is equal to 1, which is at this point now, the slope is again is going to be 2, because this function which give us the slope does not depend on y. So it's gonna give me slope 2 here. Again, x is equal to 1, y is equal to 3, which is going to give me the same slope, and y is equal to 4 or y is equal to 5. Any component which has the x is equal to 1 and any y value are going to give me the slope 2. Now this is a very interesting point. If I choose x is equal to -1, y is equal to 0, my slope is 0. And this time I will draw a tangent line whose slope is 0. So this is a tangent line whose slope is 0. This is horizontal. And again, if I choose a point, x is equal to -1, y is equal to 1, it also gonna have a slope 0. So I will draw a horizontal line here. Similarly, I will draw a horizontal line here. Similarly, I will draw a horizontal line here, and so on. And if I choose negative values of y, but you keep x is equal to -1, they are all going to give you the horizontal slope. So now if you take here, which is a point, x is equal to -2, y is equal to 0, this is going to give you -1. So negative slope means this is the tangent line whose slope is -1. Again, if I take this point where x is equal to -2, y is equal to 1, it's going to give me the slope -1 here. Similarly here, Similarly here and here. So drawing a slave field is basically taking as many points as you can and draw the tangent line of very short length. So similarly, I can take few more points here and draw their slopes. So this graph is called slope field of the differential equation. In this case, our differential equation is a dy by dx is equal to x plus 1. And as you can see that if I plot a graph here, where these are the tangent line, these are the tangent line to the graph of this function. So this is one of my special solution which passes through y is equal to 0, y at 0 is equal to 1. Similarly, this is another special solution which is a y is 0 is y at 0 is 2. And this is another special solution. So you can basically predict now some special solution to this differential equation. And as you can see, the special solutions look like a parabola, or in fact, the general solution of this differential equation is y is equal to x squared divided by 2 plus x plus c. In fact, it is a parabola. Here I have one more example. We will draw the slope field of this differential equation. So first I will plot x-axis and y-axis, and I will plot here the table. I will choose x and y independently, and I calculate the slope of the tangent line on this column. So if I choose x is equal to 0, y is equal to 0, this slope is going to be -1 in this case. So -1, it means a tangent line whose slope is -1. As you can see now, since the slope does not depend on x, so if I choose any x, if I choose x is equal to 1, y is equal to 0, its slope is also going to be -1. The slope of the tangent line here is going to be -1, here is going to be -1, and so on. Similarly, if I choose the negative values of x, so they are all going to give you the slope -1. Now, if I choose y is equal to 1 and if I choose x is equal to 0, it means I choose this point. The slope is going to be 0. It means here I'm going to have a horizontal line. And now, no matter what value of x you choose, as long as you choose y is equal to 1, the slope is going to be always 1. So all these points are going to have horizontal tangent line. So here, this is a horizontal tangent line. So all the point here, they are. There is another point which is a special. If you choose x is equal to -1, now can you choose, sorry, x is equal to 0, y is equal to -1. So you will again get the slope. Basically, this is the point, which is a x value is 0, y is a -1. Slope is horizontal, and all the points here gonna give you 0 slope. So all the tangent line on these points are going to be horizontal. Also, you can notice if you take x is equal to 0 and y is equal to, let's suppose, 1/2, like point here, you are going to get a negative slope. So it's going to be a 1, 4, -1, which is a negative. So here, if I draw a tangent line, the slope is going to be something like this. And no matter, as long as y is 1/2, all the tangent line are going to have negative slope. So I'm gonna draw a negative slope here. Similarly, if you take y is equal to negative 1/2. If you plug here again, you're gonna get 1, 4 minus 1, which is a negative. So you get a negative slope here also. Here, if you choose y value greater than 1 and x value 0, so you are going to get a positive slope. So it's going to be a tangent line, going to have a slope like this, or all the point here are going to have the same slope. So similarly, you can choose some larger y value and they plot one by one tangent lines. They are going to give you slope like that. If you choose y is equal to, let's suppose, -2, then in that case, you are again going to get a positive slope here, because that's going to be a 4 and sorry, -2, and let's suppose y is equal to 0. That's going to give me a 4 minus 1, which is a 3. So the slope of all the tangent line here is also going to be same. And similarly, you can see that as you getting larger y value, the tangent line are getting steeper. So I will draw all these. So now I can predict some solution. As you can see, if I start from here, my solution is going to be in this direction. If I start from here, the solution will stay here. If I start from here, solution stay here. But eventually it is going to be in this direction. If I start from here, the solution is going to look like that. If I start from here, the solution is gonna be this. Solution are going to be these. So these solutions are like this. So here solution are. So you might notice this solution, which is a y is equal to 1. It is a repeller because all the special solution are repelling from the solution. And this is special solution, which is a y is equal to -1, it is an attractor because it's attract all other special solution of the differential equation. Next, we will draw the slope field of this differential equation, which is a dy by dx is equal to minus x divided by y. So again, to start, I will draw a table and I will draw x value here, y values here, and the slope here, which is a minus x divided by y. So if I choose x is equal to 0 and y is equal to 1, as you can see that you cannot choose y is equal to 0, otherwise it will be indeterminate form. So you must have to choose some positive value of y. Your slope is going to be 0. So if I choose something here, so its slope is horizontal. And also you can notice if you choose x is equal to 0, y is equal to -1, you're gonna get this slope 0. So slope of this line is also gonna be 0. Or any point which is on the y-axis are going to give you a horizontal slope. Because if you choose x is equal to 0 and any other non-zero values y, your slope of the line, which is a minus x over y, is always 0. So you are going to draw the horizontal tangent lines. Now, if I take a point here, it means this is x is equal to +1 and y is equal to 0. This time I have -1 over 0, which is infinity, which is sort of minus infinity, but it means the tangent line is vertical. So I'm going to draw a vertical line here. And also you can see that if you take x is equal to -1 and y is equal to 0, so you're going to get an infinity, or in other words, a vertical line here. If you choose x is equal to 1, y is equal to 1, which is at this point, you are going to get -1 slope. So the slope of the tangent line is -1 here. If you choose x is equal to -1, y is equal to 1, you're going to get a positive slope. So this point are going to give you a positive slope or a tangent line which has slope 1. And if you choose a point here, it means x is a -1 and y is also -1. So this is going to give you a negative slope. So it's like this. And if you choose a point here, which is a x is equal to 1, y is equal to -1, this is going to give you the positive slope. So it's here. Similarly, you can choose this point and this point. They're going to give you something like this slope. So any point you choose here are going to be a vertical slope, but other point will give you something like this. So you can draw all other point and tangent line all other point. So they are will be something like this. So I can draw the one special solution. You can see this is one special solution. This is another special solution. So there are many solutions here of this partial differential or this ordinary differential equation. And as you can see that all the solutions look like a circle. And in fact, the solution of this differential equation is a x square plus y square is equal to c. So since this is the general solution of your ordinary differential equation, so slope field tell you that how basically graphically you can predict that what is the behavior of your solution. In this example, I have a system of ordinary differential equations, and we will see that how we can find the slope field when you have a dy by dx t and dy by dy t, and in that case, how you can find the slope of the tangent line. So to begin with, I will use this chain rule, which is a dy by dx is equal to dy by dt time dt by dx, and which is informally we can write d over dt divided by dx over dt. Or in other word, dx over dt is given x minus y, and dy over dt in this case, sorry, dx over dt is given minus x plus y. So now we have a differential equation dy by dx, which is the slope of the tangent line to the graph y is equal to x, f of x. So, which is x minus y minus x plus y. So similarly, we will draw that table where you choose x and y independently, and you plot x minus y minus x plus y. And here I will draw the slope field. Here is our first quiz problem. Please pause the video for 1 and 2 minutes and work on this problem. In this problem, you have to identify that which differential equations will produce the slope field in this graph. Here is another quiz problems. In this problems, you also have to identify that which differential equation will produce the graph of this slope field. Please pause the video for 1 and 2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.